Good morning, my dear students. Now we discuss Unit 2 transients, short duration and long duration variations. So in Unit 2 contains categories and characteristics of electromagnetic phenomena in a power system, impulsive and oscillatory transients. These are the two types of transients. Impulsive, what is meant by impulsive, what is meant by oscillatory, we discuss later. Interruption, sag, swell, sustained interruption, which are the power quality issues. Under voltage, over voltage, outage, source of different power quality disturbances, principles of regulating the voltage, conventional devices for voltage regulation. So now we discussed about categories and characteristics of electromagnetic phenomena in a power system. So the categories, what are the categories for power quality disturbances? What the characteristics? Characteristics means typical spectral content, typical duration, typical voltage magnitude. How much the voltage variation occurs in that characteristics. How much duration is there in that characteristics. How much typical spectral, how much the frequency content that characteristics. Now we discussed. So the first category is a transients. In transients, we have impulsive oscillatory transients. In impulsive transients, there is a nanoseconds, microseconds, milliseconds. In nanoseconds, 5 nanoseconds rises, that is a spectral content, duration or less than 50 nanoseconds. In microsecond impulsive transients, the duration is 1 microsecond rise time, typical duration is 50 nanoseconds to 1 milliseconds. In impulsive transients, in milliseconds duration is 0.1 millisecond rises, greater than 1 milliseconds is the typical duration. So while coming to the oscillatory transients will depend upon the frequency. So that will be have the categories as just like as low frequency, medium frequency and high frequency oscillatory transients. In low frequency oscillatory transients, the less than 5 kilohertz are the low frequency. The typical durations are the 0.3 to 50 milliseconds. Magnitude lies in between 0 to 4 per unit. In medium frequency oscillatory transients, spectral content have 5 to 500 kilohertz. Typical duration have 20 microseconds. The typical magnitude is 0 to 8 per unit. So in high frequency oscillatory transients, the typical spectral content are the 0.5 to 5 megahertz. Typical duration is 5 microseconds. Typical voltage magnitude is 0 to 4 per unit. In short duration variations, the first one is instantaneous. Instantaneous we divided into interruption, sag, swell. In interruption period, the typical duration is 0.5 to 30 cycles. Sag duration is 0.5 to 30 cycles. Swell duration also 0.5 to 30 cycles. There is no change in typical duration. But the typical voltage magnitudes are the less than 0.1 for interruption, 0.1 to 0.9 per unit for the sag, 1.1 to 1.8 for the swell. In momentary type durations, that will be divided into interruption, sag, swell. So the typical duration is changes, that is lies in between 30 cycles to 3 seconds. In the interruption period, in the sag period is 30 cycles to 3 seconds. Swell duration is 30 cycles to 3 seconds. The typical voltage magnitude is less than 0.1 for interruption, 0.1 to 0.9 for sag. No change in instantaneous and momentary, but the swells are changing. The swell lies in between 1.1 to 1.4 per unit. In temporary duration, that will have interruption, sag, swell, same minor, but the typical duration is 3 seconds to 1 minute for all temporary transients. So the typical voltage magnitude is less than 0.1 per unit for interruption, 0.1 to 0.9 per unit for sag, 1.1 to 1.2 for swell. So the third one is a long duration variation. 3.1 interruption sustained is greater than 1 minute. We will take it as an interruption and sustained. The typical magnitude is 0.0 per unit. Means there is no voltage present in interruption or sustained interruptions. The under voltages time duration is less than 1 minute. The voltage magnitude is 0.8 to 0.9 per unit. In over voltages, the typical duration is greater than 1 minute. The typical voltage magnitude lies in between 1.1 to 1.2 per unit. In voltage unbalance, typical duration is steady state. Typical voltage magnitude 0.5 to 2%. In waveform distortion, there is a DC offset, is a steady state duration that is lies in the voltage magnitude 0 to 0.1%. In harmonic content, there is a 0 to 100th harmonic, that is a steady state. The typical voltage magnitude is 0 to 20%. In interharmonics, that is a typical spectral content is 0 to 6 kilohertz, that is a steady state. The typical voltage magnitude is 0.2%. In notching, that is a steady state. In noise, there is a broadband, that is a steady state, that is lies in 0 to 1%. In voltage fluctuation, there is a less than 25 hertz, that is a intermittent. The voltage magnitude is 0.1 to 7%. In power frequency variation, less than 10 seconds. So next one is a impulsive transients. What is meant by an impulsive transient? Impulsive transient means is a sudden non-power frequency change in the steady state condition of voltage, current, or both, that is a unidirectional in polarity, primarily either positive or negative, any one direction only, that will have a unidirection. Impulsive transients are normally characterized by the rise and decay time, which can also be prevented by their spectral content. Spectral means the frequency content. Spectrum is the in between frequency ranges. For example, a 1.2 into 10 microseconds 200 volts impulsive transients, 1.2 into 60 microseconds 2000 volts impulsive transients normally rise from 0 to its peak value of 2000 volts. 1.2 is a microsecond, that is a decays to half of its peak value in 60 microseconds. This is the meaning of 1.2 into 60 microseconds 2000 volts. The most common cause of impulsive transient is lightning. So this is a impulsive magnitude. Please observe this waveform. So this is a negative impulse, sudden, that will changes on particular time, that will changes only particular time, not entire the wave, that is only on particular wave on particular time. So this is an impulsive magnitude, positive impulse magnitude. There is an impulse magnitude, this is a negative impulse magnitude. Please observe carefully. Impulse magnitude, negative impulse magnitude, positive impulse magnitude. So what is meant by oscillatory transients? An oscillatory transient is a sudden non-power frequency change in the steady state condition of voltage, current, or both, that includes both positive and negative polarity values. An oscillatory transient consists of voltage or current whose instantaneous value changes polarity rapidly. It is described by its spectral content, predominant frequency, duration, and magnitude. Oscillatory transients with a primary frequency component greater than 500 kHz and typical duration measured in microseconds or several cycles of the principal frequency are considered high frequency transients. High frequency transients. This is the oscillatory transients. Oscillatory transients. An oscillatory transient is a sudden non-power frequency change in steady state condition of voltage, current, or both that includes both positive and negative polarity values. An oscillatory transient consists of voltage or current whose instantaneous value changes polarity rapidly. Already that will we discussed. It is described by its spectral content, means the frequency ranges. Spectral content is a frequency ranges, predominant frequency, duration and magnitude. Oscillatory transient with primary frequency component greater than 500 kHz and typical duration measured in microseconds or several cycles of the principal frequency are considered high frequency transients. A transient with primary frequency component between 5 and 500 kHz with duration measured in the tens of microseconds or several cycles of the principal frequency is termed as a medium frequency transients. So observe the transient state. So there is a large fluctuation in initial timing, initial time period. There is a large fluctuation. After some time period that will comes into a steady state.